Okay, welcome. This is the summary mind map for physical geography for graduating classes doing elective geography 2018. This set of revision slides is very brief. It is used as a scaffold for you to run through together with your textbook. So after you look at this, you should have a textbook with you and you should be referring to the details in the textbook. Right, for chapter 1 on tectonic hazards, there are three main components to this chapter, split into the first section looking at Earth's internal structure, followed by landforms and phenomena, and lastly responses that humans take to these phenomena. So these are the three main anchor points for this tectonic hazards chapter. Under Earth's internal structure, let's look at the first component, which is a very simple, brief introduction to what is the structure of the Earth. Here you need to know where the core, the mantle, where they are found. Inner core, outer core, inner mantle and outer mantle. This is just basically to give you a larger understanding. So if you look through the O-level syllabus, it is not always tested in great detail. So keep that in mind. We also look at of slightly more importance is the concept of oceanic crust versus continental crust. You need to identify which is the thicker one, which is the newer one, which is the older one, which one has higher density and lower density, because this affects later on when we look at the type of boundaries and the type of action that happens at these boundaries between these types of crustal plates. So unlike the first component where we talk about the core and mantle, the component on the crust is significantly more important. Moving on from there, we are looking now at tectonic forces, which is basically the energy that causes the movement of the crustal plates on planet Earth. So when we look at tectonic forces, we are looking at this key concept of convection currents that occur within the mantle itself. This idea that the core is hotter than the crustal area, therefore warmer magma is pushed upwards, and as it goes upwards towards the crust, it cools down and it slides underneath the crust, pulling it away from its original location, resulting in the crustal movement itself. Now this cooler crust will then, as a result of the cooling down, sink downwards towards the mantle again, forming a convection current that is ongoing that creates all these tectonic forces. Now within this component of internal structure, the most important thing here is plate boundaries. The different types of plate boundaries: transform or shear, the convergent or the destructive, and the divergent or the constructive. Now you need to know in great detail how each of these boundaries look like, how to draw the accompanying diagram for them, and explanation for what occurs at these different boundaries. The most common mistake made by students for plate boundaries is identifying or explaining the wrong boundary given the question. So you have to be very clear. What is convergent? Convergent is when the plates move together. What is divergent? Divergent is when they move away from one another, they diverge. And then what is transform? It means they are sliding against one another. Now if you notice here, convergent, there's the oceanic versus continental, continental versus continental, and oceanic versus oceanic, right? This one has the most variations, whereas for divergent, basically it means this plate is splitting apart. So if something is splitting apart, the component on the left and the right will be same kind of plate. So when you have divergent boundaries, it can only be between the same crustal plate, OO or CC. Now for convergent boundaries, you have to understand one other very important concept that's linked to volcanic action or activity, that is the presence of the oceanic plate. With oceanic plate present, there will be subduction. With subduction, there will be melting of the old crust and the carbonized material that will force itself upwards as carbon dioxide breaking through. It is only when there is this emergence of gas that forces its way up through the continental crust itself that forms fractures, and only when you have such fracturing will there be the chance of magma emitting, coming out, and volcanoes forming. So if there's no oceanic crust involved, there will be no volcanoes. Okay, it's very unlikely. I repeat, it is unlikely that there will be volcanoes if there's no oceanic crust involved. Listed on this slide are some of the key landforms that you must know, how they are formed, where do you find them, and on which kind of crustal plate boundaries do you find these. And for volcanoes, there are two main types that you need to know what the cross-section looks like. Ideally, you should be able to draw the cross-section as well. For N-level students, labeling is a key component. For O-level students, labeling is not that common. Moving on, when you talk about phenomena related to tectonic action, the two big ones that we are looking at are earthquake and volcanic eruptions. Okay, so for earthquake itself, you need to know what the factors that cause damage. The key factors including magnitude, depth of focus, distance from epicenter, population density, time of occurrence, type of soil, level of preparedness. As I've mentioned many times in class, this area of comparison is very common. Given the various amount of factors shown here, Cambridge has shown time and again that this is a hot topic to use for open-ended questions, comparing factors or giving the question whereby you are asked to assess the impact of each of these factors. So this is very commonly used for open-ended question, the 8-mark ones. Another area linked to earthquakes is the effects of earthquakes. What can earthquakes trigger? How does humans or humanity face? What do we face as effects of earthquakes? Things like tsunamis, landslides, destruction of building and infrastructure, loss of services. These tend to come out as short answer questions, not more than 4 marks, normally 1 or 2 factors listed. If you're very, very lucky, you will get this. Pure memory work. Now, the second wing of the phenomena that is very big in your syllabus is volcanic eruptions. So for volcanic eruptions, you need to know about the impact, the risk, effect of landslides, lahars, pollution, effect on weather when such a large amount of material is deposited into the air, into the atmosphere itself. Then also other forms of volcanic eruption flow, like pyroclastic flow. So you need to know a couple of these examples that is related to this. For volcanoes, your two very core examples will be Mount Pinatubo in the Philippines and its eruption in the 1980s, as well as the historic one where we viewed the video on Pompeii, the eruption of Pompeii, Mount Vesuvius. If you cannot spell it, it's okay, just talk about the eruption at Pompeii, where there was pyroclastic flow and massive destruction of the surrounding areas. Now, for volcanic eruptions and tectonic activity, generally there are overwhelming amounts of negatives, but there are also some positives in this. Fertile soil being brought up by the volcanic material, tourism, geothermal energy, and minerals. These are all benefits that can result of these volcanic or tectonic activities in your area itself. However, as this once again has two varying factors, pro and con, it tends to come out as an open-ended question if Cambridge so chooses to bless you with simple and direct questioning. So you need to memorize certain important things like definitions of what does fertile soil mean and how does it actually come about, and does it really benefit the locals? Also other things like are there costs involved in developing these things. Now, once again, please remember geography is logical. Your answers have to conform to the norms of logic. And so if you are going to argue that being situated in an area where there's regular and frequent tectonic activity, it's because there are so many good benefits that are out of this, and the benefits way outweigh the disadvantages. Please understand that that's not logical, because the biggest disadvantage is loss of life. When we do look at loss of life as a potential impact or potential disadvantage of living near tectonic areas where tectonic hazards occur, you must understand that loss of life is the ultimate loss, and nothing can make up for that. So no matter what kind of gains you do get out of it, if there's a potential for a loss of life, humans will tend not to want to live there unless there's no choice. Okay, so the main reason for living in these areas is simply because there's no choice. Now generally, so this slide covers all the phenomena. The contents on this slide has a very high chance of coming out as variations of open-ended question. So you need to know open-ended question, the techniques that we have talked about previously, having your given factor, having your contrast factor, having a logical conclusion, and when it's an assess, instead of do you agree, when it's an assess the factors, you need to explain 3 factors and you need to come up with which is the best. So with that, we've come to the end of the first part of your physical geography. You please remember you have to go and look at your textbook, your notes for the examples, for the specific details that you need to memorize. Take a look at whatever past exercises you've done before and the answers, and this will give you a total scaffold for the learning, for your mid-year exams, for your end of the year exams, for the prelims, or for the actual exam itself. Finally, we need to look at responses towards the natural disasters, things like preparing for earthquake. What are some of the responses that man has come up with? How do we use land use regulation to prevent future earthquakes from damaging large amounts of population, property, as well as lives? How we use building design, improvement in infrastructure, how we teach our people through drills. How do we use technology like monitoring and warning systems to mitigate these impacts of these earthquakes? Now, key examples include building regulations that we find in earthquake-prone countries like America, Japan, infrastructure design, building improvements like the ones we see in Taipei 101, drills like the ones that are done in Manila as well as in Japan. Also, the monitoring and warning system that we've seen in videos previously about how Japan uses the difference between the S wave and the P wave, the speed, to have detectors detect the faster flowing one, give off the warning before the actual high impact P waves hit the area and the damage is caused. So through all this training, you actually do some preparation for earthquakes. Under this area of responses, there's also 2 forms of responses that we talked about: short-term response and long-term response. Now, this is another area that has high potential of being used for open-ended questions, because there's a comparison once again between what is short-term response, what is long-term response, or which is more suitable at which time of the earthquake timeline, and what is offered as a short-term response versus long-term response. Now, it is important at this point to note that you cannot do without either one. Okay, you need to have short-term and long-term response once an earthquake hits an area. However, there are certain things that if you apply long-term response without short-term response, then people will die. If you apply short-term response without long-term response, the people will be waiting for impending death the next earthquake. The next time the earthquake strikes again. So you need to have both, and it is important that they work hand in hand. So whenever you're answering a question that asks you to compare these 2 types of responses, the logic behind it must come out in your conclusion. You must clearly state that neither one can live without the other. You need to have both side by side. Timeline is short-term first, followed by long-term. Long-term amount of long-term response given applied to a certain area depends on how much money the government has. And with that, we've come to the end of the first chapter. Next, we're going to look at chapter number 2, which is variable weather and changing climate. So once again, I want to repeat, use your textbook, use your notes. This is just a scaffold to give you a clearer understanding of what is covered. Now, because you are the elective geography students, you will only be covering elements of weather and climate change under the weather and climate topic. The third one, extreme weather, you've been spared. The pure geog students are the only one who do this. So if you're a pure geog student out there, you may want to search for an earlier video that I may have made while I still had a pure geog class. Now, for the topic of weather and climate, we start off with a lot of definitions, a lot of hard memory items. You need to learn things like elements of weather, what is temperature, what are components of temperature, from altitude, latitude, distance from sea, cloud cover, how all these things affect temperature. This is important. Then we move on and talk about humidity and rainfall, winds and pressure, and then climate types that you need to know. So for temperature and the effects of these four factors that will affect the temperature itself, altitude is the concept of how high you are. Please remember, as you go up 1,000 meters in height, you will lose 6 degrees Celsius in temperature. Latitude refers to where the location is on the earth, along the latitude lines. If you're on the same latitude line, you should technically get similar climate types. For the idea of distance from the sea, please, this is the continental and maritime effect component, as well as for cloud cover. Please understand how the cloud serves as a buffer and as a way to trap solar radiation in the day as well as at the night. Under humidity and rainfall, you need to know what the concepts of relative humidity are. What is this cloud that we talk about, that we see in the sky? What is it made of? How does it form? The water cycle, once again, something you learn in P4, I believe, but it will haunt you until now. The concept of saturation point, dew point, and then very importantly, the two forms of rain that is in your syllabus. Okay, there are two forms of rain in your syllabus. You need to know how to explain them. You need to know how they are caused, how to draw a diagram to represent these two forms of rains. This is especially if you are an N-level student, you must learn how to draw these diagrams. Orographic rain, or commonly known as relief rain, as well as convectional rain. Under orographic rain or relief rain, you need to be able to remember these few points. Air parcel goes over water. It picks up moisture. When it is forced up the high relief feature, it cools down rapidly, condenses, and then it dumps the rain on the windward side. The air parcel will continue to rise. It now becomes a dry air parcel. As it crosses over to the leeward side, there is no rain. This idea of this progression is important in orographic or relief rain. Now for convectional rain, it is basically your normal water cycle that you learn in primary school. So you need to remember Singapore has convectional rain because we're in the tropics. We don't really have the clear monsoon seasons. We don't have relief rain because we don't have a large relief feature, but we do have convectional rain. Then what is the characteristics of convectional rain? Think of the rain in Singapore. Use your daily life experiences. It is very short but very, very intense rainfall for 5-10, not more than 20 minutes normally, and you tend to have a lot of thunder and lightning. So that's convectional rain. Under winds and pressure, I want to highlight once again, winds and pressure, you are learning about local, global winds, but the underlying theory is the same. It is about hot air rising, cold air sinking, and therefore creating a low pressure point and a high pressure point. Now with these two concepts of a low pressure point and a high pressure point, the area that is experiencing high pressure will escape. It will be pushed away. Where will it be going to? It will be going to where there is low pressure. So think of the balloon, the inflated balloon. Once you release the nozzle itself, the pressurized air within the balloon, it rushes out to the general area that is low pressure. So this concept of hot and cold, high pressure and low pressure, and the movement is the baseline understanding that you need for local wind as well as global wind. So it explains everything from land breeze, sea breeze, all the way to monsoons. Now this brings us to what you need to know. Okay, you need to know how to draw land breeze, sea breeze diagram, fully labeled. You need to know how to draw a basic, simple monsoon diagram. If you're unsure of what these diagrams look like, go into the YouTube channel once again, search through under geography learning or geographical learning, and look for the drawing components. Okay, I have all 4 diagrams there. Listen to it, practice it. It will help you. Lastly, for this component here, we are looking at climate types. There are 3 main climate types that you need to learn: equatorial, monsoon, and cool temperate. Now, how will they normally test you for this? Generally, this comes out in the data response component where they give you climographs. Okay, please remember when you're reading the climograph, if a question asks you to describe, you need to talk about what you visually see. Are there areas of sudden highs in temperature, sudden lows in temperature? Is the temperature fluctuating constantly? What's the temperature range? Similarly, when you talk about rainfall, is there a wet season, a dry season? Is it average throughout the year? Is it average on the high side, average on the low side? During dry season, is there zero rain or is there very low rain? Similarly for the wet season. Now this is description type questions. So for the climatic types, this area, it tends to be in the short answer question. It could be in section B, the accompanying 4-mark question, or it could, if it comes out in the other sections, it's also as a small component only. Now the final gateway for weather is on climatic changes. So we start off with causes. You need to know there are man-made causes and natural causes. Both will lead to climate change. Now at this point, I want to remind all of you, climate change doesn't mean global warming. Climate change can be global warming, it can be global dimming as well. So as long as there's a change in climate, in global temperatures, okay, generally that's considered climatic change. When we look at natural causes, we look at solar flares or variations of solar energy, as well as the impact of volcanic eruptions, which was covered in the first unit. Man-made causes basically are all the things we do to release carbon into the air, from industries to agriculture to burning of fossil fuels. All these things are the human causes of climate change. They're real, and generally they may ask you to compare open-ended question between human and natural factors as well. After you look at the causes, you look at the impacts. So what happens after there are all these causes of climate change? So impacts, the core impact is sea level rising, more occurrence of extreme weather. We talk about the hurricanes, the more occurrence of hurricanes, larger hurricanes, the speed of these changes in all these weather conditions, spread of disease. I think there's an error in the note there's an error in the slide. It is increase in spread, not speed. SPREAD, spread of diseases. There's a change in the growing season. Now, most of these impacts are negative. However, the last one is a positive one. If you go to the Facebook page, there's a video about Russia and how it's actually embracing this global warming phenomena. Because for them, they're getting warmer and their growing season is actually growing longer. So under the section of responses, there are international and national responses that you need to know about. The trend we've seen so far is once again comparison, 8-mark comparison question, normally asking you whether international responses are more effective or national responses are more effective, or it could be ranking the effectiveness of the 3 national responses that you learn. For international response, your syllabus only covers the Kyoto Protocol. You need to remember that the perk of this is general awareness. Everybody agrees that carbon emission actually leads to climate change, and the countries all have a larger awareness that this is something that has to be curbed or curtailed to a certain extent. Disadvantage: this is a non-binding, non-punitive treaty that in the initial occurrence, many countries, many of those large polluters like China, India and US refuse to sign. As a result, effectiveness is more on an awareness level. It is good, but it's on an awareness level itself. Now, national level policies are actual policies that have been implemented and to varying degrees of success within Singapore. So if we talk about absolute effectiveness between national and international, I think it's hard to argue that the national policies are less effective because they actually have tangible change. However, you have to, in your logical conclusion for open-ended questions like this, you have to be able to say clearly that it would be ideal if these national policies were adopted across countries, rather than having an uneven level of national policies for different countries. So once you're able to identify these varying levels of policies are important, it is useful to then come to a conclusion that both are effective depending on what your end result you're looking for. If you're looking for outreach and global awareness, the national ones are less effective. If you're looking at absolute effectiveness, then the national policies are more effective. So with this, I want to repeat, this is a useful run through for revision of exams, before exams, from mid-year to prelim to even the actual O or N level exams. But please remember, this is only the scaffold. You do need your notes, you do need your textbook for the flesh, and you do need to memorize. If you are not willing to put in the time to memorize, you are not going to have the content to flesh out the details. I also want to remind you that for the actual exam itself, this is not social studies. If you have no content, you are not going to be able to build up your open-ended questions. Is there a way to jump from a level 1 to a level 3? No. In Geog, it is progressive. You have to have all the content ready. Otherwise, your answer is never going to be just 3 sentence, 5 sentence, a level 3 answer. Okay? That happens for social studies. That doesn't happen for geography. So please remember, you're already on. So once again, I hope this has helped you in some way. For those of you who have not subscribed, I'm still wishing to hit 1,000 subscribers. So log in, sign on and subscribe to the channel. Hit a thumbs up for this video if you find it useful. If you don't, hit a thumbs up still because you've made it to the end of the video. Right? So thank you. All the best.